My name is Tyler Benson, and I am a Java agent developer for New Relic. I work on the Java agent. So first of all, this is my contact information, and you can go to this URL if you'd like to learn more about using New Relic with Play. And I will also show this slide at the end of the webinar. But for now, I'd like to just kind of show you a little bit, sorry, give you a brief introduction of what New Relic is. New Relic is a application performance monitoring tool. We monitor your production environment and applications for performance problems and provide you actionable information when something might be going wrong. So first of all, I'd like to show you a little bit of what I'm going to be demoing today. And so I'd like to start with this computer database application. And this is a sample application that can be found within your Play distribution. In your sample application folder. And this demo applies equally to your production environment, not just this sample application. Any Play application can be monitored and provide useful information. So this computer database application is right now using an in-memory database, and it's just a basic database application where you can create new elements to store into the database, or you can update existing elements. And I'm basically just applying a minor amount of load using this tab reloading tool. So the way that this looks in New Relic is, so this is what it this is the first screen that shows up after I log in. And let me go in and kind of just show you how this is performing right now. So this is the overview screen, and it shows a quick overview of actionable information. So it shows the throughput, how many requests are coming through, the average response time is really low, 5 milliseconds, and the Apdex. And I will be explaining a little bit more about what Apdex is later. But yeah, so this is what New Relic looks like. So one of the things that I thought would be fun in this computer database application is to add a stock ticker symbol next to each of these company names. And I have that feature staged in my Git repo for the computer database. And I'm just going to go ahead and apply that stash here. So now those changes are made, and let's go in and restart my Play application. I have a script here that will recompile and relaunch. I'm running this in a production mode, like James said, using the play dist command. So it's more similar to how it would run in production. But New Relic also does support the play run command instrumenting that. Just read our documentation for how to do that. So what I'm doing in the restart command, in this restart script, play dist, I'm killing the existing process, removing it, and exploding that compiled bundle of jars that Ward was talking about, that's created, or that James was talking about, created by the dist output. Next, the deployment marker. This is a marker that is visible in the New Relic UI, and it is very handy for comparing when a performance impact is caused by a deployment and communicating that to other people on your team. And I'll show you what that looks like a little bit later, but we highly encourage people to utilize this, and you can provide more information, such as the version number of an app that got deployed, or other, like a commit hash or something like that. And finally, the startup command for computer database, along with the New Relic Java agent command. This is what allows us to instrument New Relic, instrument computer database as it's starting up. So let me go in and show you kind of how this is looking. We've got, coming back here. So now we've got that that change made, and we see random performance or random errors coming through. But I'll show you how that's helpful later on. But here we've got the stock ticker symbol, and the way that this is being supplied is an external call to a public API. Actually, I think it's through a Yahoo API that I'm querying that through. So using the built-in Play WS API. So now that we've got that running, let's come and see how that is performing in our New Relic overview page. So let's refresh this. We've got our time window set to the last 30 minutes, and we can right here see the deployment marker. So this is that deployment marker that I was showing you from the deploy restart script. So this is created by that. So the other thing I wanted to kind of explain was this Apdex thing. So what Apdex is a simple way of quantifying user satisfaction for pages with different expected latency. For example, your home page, you expect to have a very low latency, and then another page like a shopping cart, you expect to have perhaps a higher latency. And you want to be able to compare the performance of those two pages and monitor those in a more understandable fashion. So by applying Apdex score, an Apdex value, which is defined as pretty much the expected latency for the page, how long users are going to want to wait for that page, then you can compare those when they skew too far. The other thing is, like you just saw, when errors happen, those also affect the Apdex score. So continuing on, let's see what's going on with our application. Obviously, the performance has degraded. So the Apdex is decreasing, and we can zoom in on any graph by clicking and dragging like this. So let's just zoom in and see what's going on. Okay, so here we see a lot of our new time is being spent in web external. So those API calls seem to be having a noticeable impact. We expected them to have some impact. Obviously, when you're making external calls, you're not going to have an 8-millisecond response time like we were having. So we were expecting some performance degradation, but this is still pretty significant. So let's dig into New Relic and see what's going on. We can click over here to the Web Transactions tab, or we can click directly to the web transaction that is performing poorly down here. So let's just click on this tab and see what's going on. We can filter our information by clicking on the specific controller that we want to analyze. And here we see the sub method and class level interactions of our application. We see the throughput has dropped significantly, and we're seeing a whole lot of time being spent in the async HTTP client, which is what the Play WS API is using under the covers. So obviously that's causing some problems. Let's let's see if we can get more information. We can also click here on the app server breakdown, and we can change that from an average response time to a percentiles. And that'll give us a different view showing the median, average, and 99th and 95th percentile of how that's performing. So let me reload and see if we've got any more up-to-date information. Actually, I think I need to change my time window to more current, so we've got up-to-date. So let's see, here we've got a breakdown, and down here we've got some transaction traces. Transaction traces are basically a snapshot of an individual web request and how it spent its time. So let's dig into that and see how that's performing. Obviously, these response times are very high and probably causing some pain for our users. So let's dig in, and we're again confirming we're spending a lot of time in the async HTTP client. Maybe our trace details will show us some more information. This is a breakdown, very detailed, of how that spent its time, and we see a lot of those async HTTP calls. We see a lot of duplicates, so like we don't obviously need to call ASYS 3 times when all we're trying to get is the stock ticker symbol. Those are going to most likely return the same result every time. So let's try and optimize that by adding some caching. So here is our models.scala from within the computer database application. I added this ticker method, and let's go ahead and add some caching. So this will cache the responses from the service, and using the built-in play cache API. So now let's restart this, and hopefully that will improve our performance a little bit. So while I'm waiting for that to restart, let's talk a little bit more about this transaction trace. Play, as James said, is a very asynchronous distributed application. It utilizes all the cores of your CPUs very effectively. And as a result, it makes it a little more challenging to track that interaction. So in order to follow that transaction across threads, we add these async wait nodes. So whenever you create a promise or a future or something that's going to be happening on another thread, that is captured in this block. And that allows us to show how distributed your application is. Another thing that I thought would be interesting for you is to show you how how we capture the database time. So this is a database application, and because it's an in-memory database, we expect them to be very fast queries. So we can show those fast queries by selecting this so they're not filtered. And here's our query that we're making, and let's come back to that in a little bit. But for now, that's how you get into there. So let's see if we've got updated data and see how our application's performing now. Let's switch back into the web transactions. And just to give you a broader view of how our application's performing, let's go back to the 30-minute window. So we see this is our performance before the feature, and then we did our deploy, and now we're back into this is the poor degradation of our application. And it looks like we're still waiting for a little bit of data. So let me show you kind of some other features that New Relic provides through when we're collecting that API, when we're collecting external calls. So one of the nice things that you can see is this application map, which shows you kind of an high-level overview of how your application is communicating with other systems. So we see the end user communicating in with this Tyler's application. This is the computer database. And from there, it's communicating with this API call to the Yahoo get the stock ticker symbols, as well as the database interactions. So that is pretty handy. So let's see if we can go back to the overview, and I'll show you another cool feature, which is as you saw when I was loading earlier, we saw some error pages. Those are obviously going to be frustrating for users, so we classify those as frustrating, and those affect your Apdex score. It looks like our Apdex dipped down, so we would have gotten an alert probably down here, but then it improved after our recent deploy. So that's good. Let me dig into our web transactions and see if we've got an updated view of how that's performing. Our change has definitely improved performance. We're down here, but definitely not as good as it was initially. Let me zoom in. And see if we've got any more recent transaction traces. Let's try one of these more recent ones. So this should have been after my most recent deploy. Looks like my call count is down significantly, but the performance is still not very great. I was expecting a lot fewer a lot fewer API calls, since on a given page we're filtering it to about 10 requests, 10 different companies. So maybe there's a problem there. Let's go back into the transaction trace details and see if there's something else. So it looks like we're making a lot of different calls. This is the page that we're loading, so we're not seeing the duplicates, so that's good. The caching's working. So that's a big impact on reducing the performance, but it looks like we're still making a lot more calls than we need to. Let's look at the code and see if we see any problems. The function that I'm calling is this list. This is the code that's being called to query the database, and it looks like the developer left out some important limiting code, perhaps for testing or development. I don't know, but yeah, that's definitely going to impact performance right there. Let's see if this helps. They're not proper. It's not good to bring back all the data when you can limit stuff like that in the database. So let's relaunch that and see if it improves our performance. Another place that we could see that is again in the SQL statements. If we click on the show fast queries, we see that there's not the proper limiting SQL on that call. So while we wait for that deployment, let's look at a couple other features in New Relic. So ahead of time, when we had added this feature, we wanted to track our real user performance, how our users see our application performing, which includes the browser rendering and network traffic. And the way that we do that is by adding these JavaScript little tags into our template. And by adding it here, it affects all of my play templates and makes it a lot easier rather than having to modify that on a bunch of different play individual HTML files. So by adding the header and the footer, New Relic will add a little bit of JavaScript to those header and footers to track the timing. And the way that that looks is in the overview. For example, we can look and see instead of just the average server response time, we can click and see what the browser response time is and see that breakdown. Let me zoom out to show you a fuller view of that over time. And so we see before our change, most of our time was spent in DOM processing and page rendering. The application was very fast, and so that's good. This is obviously very positive for our user interaction. But after our change, the web application was taking a lot bigger chunk of that time. Even with the second change we made, it was still a big chunk, and also affected our browser throughput. Another cool feature that that RUM allows us is for tracking different geographies, different locations, how that web page is performing. So, for example, if you're mainly focused on a United States geography and all of your servers are in the US, then you would see, if you went over to the geography through the RUM headers and footers, you would be able to see how that's performing in other countries like Asia or Europe. And then that would allow you to focus on where your users are hurting the most. Another feature that I kind of hinted at, but I'd like to show you, was the errors logging, our errors collection service. So when a user hits an error screen, that's going to be kind of frustrating for them, and we collect that as an error. And if you come into our errors events, you can actually see what that stack trace is. Rather than having to hunt through your logs, you can come here and see what might be causing that exception. And so this is helpful for digging up problems that are affecting your users, especially if you have an individual deploy that is problematic and all of a sudden your error rate spikes up. You can dig in and see faster what might be the cause of that error within that deploy. The other cool thing is inside of, so when you're monitoring your application through the Apdex and through New Relic, we allow for alerting on that application. So here we've got all of the different events that are happening, and when performance goes poorly, then you can be alerted on that, and the alerts show up here. Whoops. And so, for example, yesterday or Monday, I had an alert come through, and this is basically a collection of events that happen to affect the performance of my application, and or not affect the performance, but to demonstrate the degradation of performance. And so this can be sent to multiple people, and you can see the alert policies and modify those so that it can be sent to different people based on different events. So that's our alerting feature. So let's see if our application's back and performing well. Okay, so we've got our recent deployment here. Let's let's go back into our web transactions and see if we're back to an acceptable response time for the user. So our Apdex has come up a lot more. we're back up to 1, and let's switch back to the app server response times. And so now we're back under 20 milliseconds for average response, so that's good. Let's click on the problematic transaction set and see how those are performing. We're back under a 50 millisecond response time, so that's decent. It's definitely not the 8 milliseconds that we started with, but it's certainly an improvement. We're back down into an average of 3 external calls per transaction, and so I think that that's a great representation of how New Relic can help you improve and monitor your production environment. And right now, I think let's go ahead and open this up to questions, and hopefully that was helpful for you guys.
Great, thanks Tyler. Really appreciate it. Looks very cool, and definitely looking forward to adding this to typesafe.com, which is of course a Play app. So we're going to answer some questions now, and so you can enter those into the questions pod and we'll go through those. Also, if you didn't get a chance to join the polls, I'm going to try to relaunch the polls. It may not be possible. Yep, actually, it's not possible to relaunch them once we've closed them. So sorry about that if you didn't get a chance to answer the polls, but we are answering questions. So give us a second while we go through the questions that have been coming in and start looking through those. And then Tyler, can you also put up that slide so that people can see where to go to get more information and where to get started? Great. Okay, so newrelic.com/java/play to get information on how to get started. Cool. Okay, so we've got a bunch of questions coming in. We're going to be going through these and answering these.
I'd like to take this chance to thank James and Typesafe for the opportunity to present and share about New Relic. It's Play has been a very fun framework for us to dig in and instrument and learn how to handle the asynchronous nature of it. It's been a pretty good, pretty fun challenge. So
good. Well, thanks so much for showing us how to do this. It's very exciting. Great. So there's a question about what the get browser timings header was, and I think you explained that, but maybe I'll start with saying that you'd added that to the main.scala.html file, which was the main template that is used throughout the application for all the web pages. So that has in that file the HTML template, the head, the body tag, and then the rest of the templates fill in the body part of that template. So then, Tyler, what was the get browser timing header there?
So what this does is this calls out using the New Relic API, which I've added as a dependency in my Scala build file. Since we deploy that API to Maven, that's accessible through the Scala build SBT dependency. So after adding that, I was able to add this as a static call, and what this does is it generates a little timing information for rendering the page. So what it'll do is it'll add basically a little start time to set kind of a JavaScript variable showing when it started, and then once we get to this end tag, it will capture the difference between those two and use that to kind of measure how the performance of the page rendering was.
Great, and that's just pulling in some JavaScript. So if somebody's not using the server-side templating in Play, they could just get the JavaScript code that's generating and put that into their web pages as well, right?
No, you have to. It only works when using the browser, the API call, because we include specific information about that individual transaction, and so you can't just copy the static JavaScript into your template.
Got it. Great. That's helpful. Okay, let's see. There's a question about how would you instrument an AngularJS application?
So we have a browser monitoring, sorry, we have a JavaScript instrumentation team that's working on better instrumenting JavaScript in the browser. And I don't think we are quite there with Angular yet, but it is definitely something that we're working on, especially since um, we are starting to use Angular internally. So we're definitely wanting to instrument that better.
Great. Yeah, and to touch back on the previous question a little bit, there was a question about how this would work with an application without any HTML. So if you're just using Play for REST services, then obviously you wouldn't have the templates like we're showing here. But that doesn't mean that you wouldn't get all the other information that New Relic is adding to your application through instrumentation. Is that right, Tyler?
So, sorry, can you repeat the question?
Yeah, so if you're just using Play as a REST service, you're not going to get the browser view of the data, but you'd still get all the other useful transaction monitoring and transaction performance analysis stuff
Right.
if you're
So
just doing like JSON.
if you're using Angular with your Play application, we'll still capture all the stuff that happens on the Play side of things. We just won't necessarily capture the information that is happening within Angular. However, we still will show some browser metrics if you have the browser timing header and footer API calls in your template.
Cool, great. So there's a question about you used production mode for this particular demo, but you could certainly use this with development mode as well if you wanted. Is that right?
Yeah, the way that we support that is by modifying a build script within your Play installation to add the Java agent startup command to uh, your Play startup. So that way, when Play starts up, using the actual Java call, it'll instrument Play and allow you to instrument the server while it's starting up in dev mode.
Great. Let's see. There's a bunch of questions and we're hunting through them. Um, and if you don't get your questions answered today, feel free to send me an email, james.ward@typesafe.com, and we'll get your questions answered.
You can also
Um,
contact me directly if you have something about New Relic.
cool. How would New Relic and Play work with a PaaS provider like Cloudbees or Heroku?
We actually have support for them directly. Both Cloudbees and Heroku uh, allow us to be added as a plugin, I think, and that makes the installation very simple. Uh, from there, you can log into your Heroku application, and then they have a little link that links you to our website directly. So that way, you don't have to worry about having a separate account for New Relic and for Heroku. Um, and I think that Cloudbees probably has a similar arrangement. And from there, what you can do is you, you basically set the New Relic startup command in your I think it's your proc file, your startup script. So that way, when it builds the distribution, it will launch that with the New Relic agent and log directly to New Relic from there.
Great. Um, Let's see. There's a question about can you use this with any kind of load testing systems, and yeah, definitely. Your Play application you can do a load test against. There's all sorts of different tools to do that. Blitz.io is one that was mentioned in the question. You can also use local applications to do your load testing. There's a really great one called Gatling, which is a kind of new system for running load tests. You can run that locally, very similar to like JMeter.
Yeah,
So
and
yes,
having New Relic instrumented in your load test environment will definitely help highlight where your application might be performing poorly under a load. So if you've got like a database query that performs fine under normal circumstances, but gets slow after heavy traffic, the New Relic would help you highlight that.
great. And one thing to point out on that, if you do want to do a load test of a Play application, definitely be running the application in production mode using player activator start instead of run. The difference is that run on every request will do a bunch of checking of the file system to see if any files have changed. And of course, when you're running a load test, you don't want that bogging down your system. So make sure you're running in production mode when you do any kind of load testing on Play.
One thing I'd like to highlight, though, James, is we weren't able to figure out how to have New Relic tie in and instrument the play start command. So we only support using play run for dev mode or play dist and then using the external distribution.
Yeah, and you could also use PlayStage as well. PlayStage is the same thing as Playdist, just without zipping up everything at the end. So
Okay.
good thing to know. There's probably a bug that we need to be working on the Play side to make sure that you can do that with just the regular Play start. Um, Thanks for all the great questions. We uh, definitely digging through these. There's a question about what versions of Play are supported.
So we support Play 1.2.5 all the way up through Play 2.2.1 right now. So we're trying to add support for new versions of Play as soon as they're released, and yeah.
Great. 2.2 RC2 just came out, so I'll have to check and make sure we didn't break anything.
Okay, yeah, we
In a
will
dot
too.
release, we shouldn't be breaking things, but and let's see. Is there a way with New Relic to correlate calls across two different applications? So let's say I had a web kind of web front end Play application, and then I had some back end service, maybe Play, maybe some other technology, and I'm making a call from one application to another application. Is there any way to correlate those two calls?
That's a great question, and it's something that I actually forgot to highlight in my demonstration. When you are communicating, so for example, on this map, when you're communicating between two different applications that are within your account, if they're both instrumented with New Relics, so for example, say this API call that I'm making here was a New Relic instrumented application that you own, it would communicate through cross-application tracing is what we call it, and allow you to link those transactions. So for example, when we were back in our web transactions and let's say we were here in one of our transaction traces. If we're looking at the trace details and we see those external calls, for example, down here, all of these external calls would also show a link to the transaction trace that's happening on the other account. And so it's a definitely a good way to dig in to applications that are happening that are communicating with each other and tracking that across different machines. So
That's very cool. Cool. There's a question about how do New Relic and Typesafe Console relate? And Typesafe Console was a product that that was initially targeted at doing production monitoring of Typesafe platform applications. We're actually just recommending you use New Relic. It's a much more powerful tool than Typesafe Console. We have integrated the Typesafe Console now into Activator, and we're working on making the console within Activator something that's much more about your development time debugging than about production monitoring. So that's a good question. Is there any way to monitor custom business metrics?
So custom business metrics are something that we are working on, and if you look at a new tool that we just announced at our conference, the FutureStack conference, I think it's codenamed Rubicon. You know, it's a way for you to report metrics up to New Relic and be able to query for those real time in a more simple fashion. Another thing that you can do is using the New Relic API, you can report individual parameters to your application that would then show up here under custom parameters. So for example, right now we just capture a couple pieces of information for the transaction, but you're welcome to add more individual parameters, like for example the user that might be logging in, or you know, different sales metrics or order size or shopping cart information, that kind of thing, that would definitely help make it easier to debug on your side of things.
Great. There's a couple questions about the ugly names in the logs and the method names having lots of $signs and that sort of thing. And unfortunately, that's a side effect of people writing Scala code that use a lot of anonymous functions, and those anonymous functions have to have names, and so the names that they're given aren't very useful. And so you can handle that on your side when you're writing Scala code by not using anonymous functions readily. Give functions names, and then you'll get something logical in New Relic. But there's the code example that was posted into the questions was one that's outside of the scope of user code. It's down in play code, and so there's probably some places in play where play could provide much more meaningful names for things, and so that's something that that we would love to get a bug or a pull request filed for.
Yeah, just to reiterate that, you know, even in Java code, if you're writing a lot of anonymous inner functions, then those are going to get compiled into a lot of dollar, you know, one kind of syntax, just like this. So it's not something specific to Scala, but it's something that Scala uses more so than I think a lot of Java code to support their type system and their functional paradigm. So
great. Okay, one last question and we'll wrap up. There's a
but
question. Oh, sorry. Go ahead.
no, go ahead.
Okay. One last question was, what's the overhead of the agent, the New Relic agent?
So that really depends. We try to keep the overhead as minimal as possible. Is definitely under the 10% range, but it really depends on your usage. If you have a very low latency application, so like sub 20-30 millisecond range, then the overhead will probably be a more significant percentage. But for most applications, we try to keep that less than 10%, generally closer to 5%. So, yeah.
Great. Great. Well, thanks so much, Tyler. Really appreciate you taking time to show us New Relic, and it looks incredibly awesome. And looking forward to using it on typesafe.com. Thanks everyone for attending. The recording will be posted on our YouTube channel in the next day or so, and look forward to seeing you on a future webinar. So thanks for attending.
Thanks, James.
Thanks.